Guys, sorry, my schedule is completely screwed up. So those are the circuits that I quizzed you the other day for the entrance lab. So let's go over those anyway, just as a review for tomorrow's test. So first thing I want you to do is to show me the flow of the current. So this is the negative, this is the positive side. So negative allows the current to leave, right? And the current keeps on going. There's no way to branch, so keeps on going exactly the same amount of current, keeps on going exactly the same amount, and keeps on going here. So the current is just one value here. The same value is going through R2 and through R1. So when you have a situation like this with the current going through, the same current go through every single one of those resistors, you have a situation that is a series circuit. So once you know that your circuit is a series one, then you need to come up with a table, right? The VRI. Okay, make sure you label everything for points, guys, and make sure that you put your units everywhere they belong. So here you have R1, which is 3 ohms according to the data that I gave you. R2 is equal to 1 ohm according to the data. And then you have the V equivalent is the one that I'm giving you, 12 volts. The R equivalent, well, this is a series circuit, so the current is just the same throughout. The resistors are just the sum of those. The equivalent resistor is just the sum of those two resistances. So it's going to be 3 plus 1 is going to be 4 ohms. At this point, the current, which is the equivalent one, so this is the equivalent, is the one that comes out from the battery. Every single time, the equivalent resistance is the one that comes out from the battery. Okay, so at this point, you do 12 divided by 4, right? Because your equation is V equal Ri. So I is equal to V divided by R. So 12 divided by 4 is equal to 3 amps. But we just said this current is the same throughout. So this is 3 amps everywhere. So it's the same throughout R2, right? So the current through the resistor 2 is going to be 3 amps. And the current through the resistor 1 is also going to be 3 amps. So what's different? Well, the voltage is different because 3 times 3 is going to be 9. So the voltage here, if I have the voltmeter here and I'm reading, right, and I'm reading the number, I read 9 volts up here. If I put instead the voltmeter across R2 here, right, and I read the number, okay, I will read a 1 times 3, I will read a 3 volts. When I add them up, I have 12 again. So this is what's going on in a series circuit. When you instead you have a circuit like that, this is a parallel circuit because the current comes out from the battery, goes here undisturbed, but when it reaches this node, it has 2 chances. Can go here or can go here. So this current I, okay, which is the I equivalent because it's coming out from the battery, is going to go into I1 and then eventually in I2. And this is the current I on the wire, okay? So how am I going to find those values? Well, I got to keep in mind that those resistors are directly connected to the battery. So I know that the voltage across R1 is 12 because I see it from here. This is 12 because it's connected to the battery. This R2, right, is also connected directly to the battery. So in a circuit that is the parallel one, I still have the V equal Ri, okay? So I have V1, R1, and I1. I have V2, R2, and I2. And then I have the V equivalent, which is the one I gave you, the R equivalent, which is the one I have to calculate. I have I equivalent, which I'm going to calculate. And also because of what we said, and because this is a parallel circuit, the voltage across every single resistor is always the same. So this is 12 volts and this is also 12 volts. At this point, I write down those values because I gave it to you, 3 ohms and 1 ohm. Then when I do 12 divided by 3, I have 4 amps here. When I do 12 divided by 1, I have 12 amps here. Then the other thing that I need to do is to basically calculate the R equivalent, which I want to know, okay, because I want to see this expression. So 1 over 3 plus 1 over 1, obviously. Okay, so whatever this value is, you got to put it there. It has to be smaller than 1. And then the current, I will do the 12 divided by this number, and I will have the number here for the current. So let's calculate the resistance. Okay, so I got to do the 3, right? So this is the calculator. So I got to do 3, and then I do x negative 1 plus 1, x negative 1 doesn't do anything, enter, and then x negative 1, enter, and I have a 0.75 ohms. Then I do 12 divided by 0.75, and I have 16. Then I go here and I double check, is 4 plus 12 equals 16? Yes. Then I've done everything right, and this is 100% in your test. Then other circuit. So this is the other one that I gave you, and we did this together in class. So we calculated this value. We didn't calculate anything. This is so our equivalent goes here, right? V equivalent goes here, and then I equivalent goes here. So V equivalent, I gave you 12 up there, so this is 12. Because this is parallel, I can just put down V1 equal 12 volts, V2 equal 12 volts, V3 equal 12 volts. So V1 means the potential here, the voltage here. R2, V2 means the potential here, voltage here. This means the voltage here. V4 means the voltage there. And V5 means the voltage here. All of those are 12, not 13. 12 volts and 12 volts. At this point, technically, this circuit is easy, right? Because I can calculate all of those right away. So 12 divided by 10, I have a current across R1, which is 12 divided by 10 is 1.2 amps. And then I go and check current that is going across R1. Which one would that be? So this is going to be the I equivalent, right? That is go here, but this, okay, this is I1, the current that will go through I1. So this is 1.2. Then the current that goes across R2 is this one. So this is I2. I2 is equal to 12 divided by 1. So this is going to be 12 amps. So this is 12 amps. Then, so I still don't know this current. I don't know this current, right? I don't know this. I don't know this. I will not know this. I will not know this yet. And I will not know this kind of. Okay? So, but I will know I3 because it's the current that is going through R3. So I3 is going to be 12 divided by 2. So this is 6 amps. And then V4, I4 is the current that is going through. Okay, so one sec. So I3 is the current here. So this is 6 amps. Then our I4 is the current that is going through R4. So it's going to be the 12 divided by 5. So this is 2.4. Okay, amps. So this is 2.4 amps. And then the fifth one actually is 12 divided by 3. Okay, but this one doesn't branch. This keeps on going across. So I5, okay, is the same throughout. So I5 is 12 divided by 3, so this is 4 amps. Okay, so this value I know. So this is 4. Okay. I still have to calculate every single one of those. How would I do that? Well, if I know this value here, then I can keep on subtracting every single current that I'm losing through those branches. So I need to have the equivalent resistance first. So how do I calculate the equivalent resistance? It's going to be 1 over 10, here, 1 over 10 and 1 over 1 and 1 over 2 and 1 over 5 and 1 over 3. Okay? So let's do it here. So it's going to be 10 inverse and 1 inverse and 2 inverse and 5 inverse and 3 inverse, enter inverse, and this is 0.47 ohms. Then I do 12 divided by, so 12 divided by 0.47, and I have 25.5, okay, as a 53, whatever, as a amps. Okay, so 25.5 is this current here. So 25.5 is the amps coming out from the battery. I'm losing 1.2. So this one minus 1.2 is going to be 24. So this is 24.33. So now I know this value. I'm losing 12. So here now I have 12.33. Now I'm losing 6. So now I have 6.33. I'm losing 2.4. And I have 3.93, which is basically 4 because of our rounding. Okay, we have lost something. Okay, so this is coming to, so the 3.4, the 4, you can say 4, doesn't matter. So the 4 is coming out from here and is joining, okay, it's meeting the 2.4. So here I'm going to have the 6.33 again. 6.33 is meeting 6, so this is going to be 12.33. 12.33 is meeting 12, so this is 24.33. Okay, and then I'm meeting the 1.2 to have the 25.5 again. And this is all done. There's nothing else you can do about those circuits. So now about the homework. The first problem said to do to deal with those. So first of all, I got to build my table. Okay, and guys, you're going to have the table to do, so you got to do exactly what I'm doing, and plus you have to answer questions according to your table in the quiz and plus portals, like you did the other day for the entrance slip. Okay, so here you have R1, which is 3 ohms, R2, which is 5 ohms, R3, which is 2 ohms. Okay, then you got to have a R equivalent, I equivalent, you got to have I1, I2, I3, you must have V1, V2, V3, and then let's go and see how we can apply this. V equivalent is 15 volts. So first thing you got to say, is this parallel or is this series? Well, the current is going here, comes here and starts branching. Some goes here, some goes here, branches, some goes here, some goes here. So this is a parallel circuit. Once we got this in place, we know how to calculate the R equivalent, which is 1 over 3 and 1 over 5 and 1 over 2. Then at this point you put everything in the calculator. So 3 inverse and 5 inverse and 2 inverse, enter inverse, and this is 0.97 ohms. So 0.97 goes right here. Okay, then the I equivalent, what is it? Well, I got to divide 15 divided by 0.97, and I have 15.5 if I round up. Okay, those are the amps. Okay, at this point it's just a game. So this is a parallel circuit. Parallel means all those voltages are the same. So I can fill in this table saying 15, 15, 15. Okay, at this point 15 divided by 3 is 5 amps. So this current here is coming out from the battery. Okay, so out from the battery means this is 15.5. Then across R1 I have this current, which is 5. Okay, then across R2, okay, I have 15 divided by 5, this is 3 amps. So this is 3, okay, so this is 5 amps, 3 amps. And then across R3, I have 15 divided by 2, which is 7.5 amps, right? So this is 7.5 amps. Then my only problem is to calculate those two currents, which is not really a big problem because I start with 15.5. I'm losing 5, so I have 10.5 here. 10.5, I lose 3, so I have 7.5 here, which makes perfectly sense, and I'm done. Next problem. Number 2. So this is still parallel circuit. The current's coming out from here, going here, and then branches, some here, and then it branches, some here, and then it branches, some here, and keeps on going all around. Okay, so this is parallel. Okay, then let's build a table. V, R, I, V1, R1, I1, V2, R2, I2, V3, R3, I3, V4, R4, I4, and then we have the equivalency there. So V equivalent, R equivalent, and I equivalent. Okay? So V equivalent is 12. We define this one as a parallel circuit. Parallel means all those voltages are the same. So 12 volts, 12 volts, 12 volts, 12 volts. Resistances, which values are those? Well, I have it right here. So this is 7 ohm, 4 ohm, 10 ohms, and 12 ohms. Then I know this is parallel, so I can calculate the R equivalent. So this is 1 over 7, and 1 over 4, and 1 over 10, and 1 over 12. And this gives me A, so 7 inverse, and 4 inverse, and 10 inverse, and 12 inverse, enter, inverse, enter, and this is 1.74 ohms. Then I go here and I write 1.74 ohms. Then the I equivalent is what? Is going to be the 12, right here, 12 divided by 1.74, and this is 6.9 amps. So this is the one out from battery. Okay, so this is 6.9. Some is going here, some is going across. How much is this one? Well, this is 12 divided by 7. 12 divided by 7 is going to be 1.71. So 1.71 is coming here. So how much am I losing? Well, let's round everything to 1 decimal only, actually. So this is 1.7, okay? So 6.9 minus 1.7, so this is going to be 5.2. So 5.2 is here. Now, some I'm losing here. How much I'm losing? Well, 12 divided by 4. So this is 3. So this is 3. 5 is coming here. 3 I'm losing. So this is 2.2. Then I keep on filling the table here. 12 divided by 10 is 1.2. Right? So 1.2 is across. So again, I3 is across R3. So this is 1.2. I start with 2.2. I lose 1.2. So this is just a 1. 12 divided by 12 is 1. Okay? And then I just, to double check, I add them up and I see if I go to 6.9. Looks like number 3. So here, again, I take the pencil, I start going around the circuit. I never have to branch off. I keep on going without raising the pencil. So this means that this is a series circuit. Series circuit means I just add up every single one of those resistances. I add them up and I have a 37. Then I start building the table, okay, VRI. So I put all those values for those resistors. I calculate the R equivalent and I write it right here. But if in this circuit the current is always the same, right, because again I don't have to branch off ever, then I write this value. I calculate the I equivalent, right, 0.9. When I do 30 divided by 37, I have 0.8, which is out from the battery, and I fill every single one of those cells right here. Then at this point, the only thing I need to do is to apply the law, Ohm's law, which is V equal RI. I multiply those values and I calculate and I find every single one of those numbers. So this is 1.6, 0.8, 3.2, 4.0, 8, and 12. And if I add them up, I have 29.6, which is very close to 30, so that's fine too. Then the last one was the one that was a little challenge and will be probably extra credit in your test. Can you solve this? So this is actually a complex circuit. Okay, it's complex because you have two different things to go over here. So here you're starting from the current coming out from the battery. Okay, you go here. Now you got to raise your pencil. You cannot keep on going because some goes here, some goes here. So this part here is a parallel, okay, circuit. Then current, okay, so I come here and then I have to raise the pencil also. So this is branching, this is going here, okay. But then between those two, I keep on going with the pencil, okay. So I go here, I go around, I do not rise up the pencil. So those two resistors are in series, okay. So basically what this means is that those two resistors being in series, I can find the equivalent between those two and calculate the equivalent resistance. So now I have a circuit that looks like this. So I did not touch R1. This is still R1. I did not touch R2. Okay? But instead of R3 and R4, I'm having a resistor that I will call it R3, 4. So this means this value is not 2, right? Because R1 is 3 ohms. R2 is 4 ohms. But this one is 2 ohms. This one is 1 ohm. But when I consider 3 and 4 together, because this is a series and I calculate the equivalent resistance between those two, then I got to add those up. So this is going to be 2 plus 1 ohms. So this is 3 ohms now. So I go again, I start my circuit again. I go from here, I go here. Now I got to raise the pencil because some current goes here, some goes here. I got to raise the pencil again. Some goes here, some goes here. Right? So this means now this part here is a parallel circuit. And I will treat it as such. Okay? So this I'll do as I used to. Okay? So I do the V, R, I. Okay? I have R1, R2, R3. And R4. And I need the R equivalent also. Okay? So R1 is 3 ohms. R2, actually here I don't have, for this circuit here, okay, for this circuit I'm going here, I do not have 3 and 4, I have a 3, 4 together, right? So R2 is 4 ohms, and R3, 4 we just found to be 3 ohms, okay? So what is the R equivalent? Well, the R equivalent is 1 over 3 and 1 over 4 and 1 over 3. Okay, So I will calculate this as I used to, right? And I'll do the 3 over and the 4 over and the 3 over, enter, over, enter. So this is 1.09 ohms. And this is the equivalent for this one, 1.09 ohms. Also, I gave you the 12 volts as a value for equivalent, V equivalent 12. So the current, okay, in this coming out from the battery, the I equivalent, okay, is going to be, so let's do those lines again. Okay, so the I equivalent is going to be the 12 divided by 1.09. So this is 11, okay, 0.01. So 11 amps is going to be the current. But this part here we just said is a parallel circuit. So I1, I2, and I3, I don't know the values of, but I know the V1 is 12, V2 is 12, V3 4. So this voltage here, okay, is 12. Okay, so at this point, what do I do? Well, at this point, I just do the division again. So 12 divided by 3 is 4 ohms. 12 divided by 4 is 3 ohms. Okay, so 11.01 is the coming out from the battery. Across R1 is the current, ohms, wow, is amps, right? So this is 4. Then I lost from 11, let's say just 11, okay? From 11 I lost 4, so this is what, 8, 9, 10, 11, no, it's 7, no. So 7 is here, right? So 7 now is branching off because some is going through R2, which is 3, right? So this means that here the current is 4, and it's always 4 because I don't rise the pencil, okay? So 4 amps is the current that is going through those resistors. Okay, so at this point basically we're done, unless you're super cool and you say, well, the current that is going through R3 and 4 is this also. If I go back in the circuit, right, if this is 4, then I can just calculate the voltage only across R4, right? So V4 is equal to R4 I4. And this one instead, the voltage here is going to be V3 is going to be R3 I3. R3 I3. So this one, the V4 will be R4, which is 1 times the current, which is 4. So this is 4 volts, okay? And this one instead is 3. The ohms are 2 times 4 is 8. So this one will be 8 instead. Okay, which 8 plus 4 is 12, which is giving you the current here, the voltage here. So this is basically, but again, don't worry about this one if it is complicated. Obviously this is just extra. Okay, make sure that you know everything about the series circuit and the parallel circuit. So make sure that you can solve fast problems like number 1, 2, and 3. Okay, and any kind of questions that I can ask, like, okay, tell me what is the current across R2. Then you take R2, you go across, and you see, okay, this is the current, what is the voltage? Well, this is the voltage, and you use the table to answer every single question. If you have any questions, please let me know. Sorry it was so late. Bye.